Well, you can't have both. We're looking at the trade-off between margin of error and level of confidence. And the distance between the sample estimate and the endpoints of the confidence interval, that's called the margin of error. So there's a little formula there. But you know what? If you've been following my sequence of videos, you'll know that margin of error formula is actually part of our confidence interval determination. Okay, you can see it there. So it's p hat take the margin of error and p hat plus the margin of error. Okay, so it's actually just incorporated into the confidence interval. Graphically, we can see it here. There's margin of error, E, and you can see it there. Okay, also it will exist here, either side of the mean. Now when we take a sample proportion, that takes the place of mu. So you can see that the margin of error is basically either side of the mean, of the middle there, and basically if we take it and add it to p hat, we get our confidence interval. Okay. The area under the curve is called the confidence level, and by the way, that's often denoted by alpha, the confidence level, the area under the curve alpha. And that's when we model this scenario with a normal distribution. We've seen a lot of this stuff before. So when we're talking about the margin of error, it's basically that part of the confidence interval determination. Alright, so once again, we have our confidence interval, which is made up of two lots of the margin of error, either side of the mean, or p hat, and the area under the curve is the proportion of all the values, and that is called the confidence level alpha. So summarizing so far, the confidence level alpha is the proportion of values that lie within the interval. And that we've seen 90% confidence, 95, 99, and there are others that are used. The margin of error is the distance of the ends of the interval from the mean, and that's either side. And those two together create the confidence interval, okay, when we have the margin of error either side. The largest margin of error, interestingly enough, is when p hat equals 0.5 for a fixed value of n and a fixed level of confidence. You can try that yourself, okay. The width of the confidence interval, and thus the margin of error, will increase as the confidence increases. Okay, so the width of this blue zone will increase as the confidence interval increases. Okay, it gets wider. And I guess the central concept of this video here, to be more confident that the interval will capture the true value, the wider the interval it will need to be. It'll need a wide interval to be more confident, okay? So therefore there's a greater margin of error. Okay, the margin of error has to be greater. So that's that trade-off I was talking about there. So more confident, the true value of the population proportion is even more likely, or has a high percentage of being in this interval, but of course the interval's got to be wider, so therefore the margin of error is greater. So greater margin of error for more confidence. Less confidence, okay, we have less error, okay, but it's less confident. The author Steve Phelps is there on the screen, just to acknowledge this. This is from GeoGebra, and this applet shows this, that we can muck around. Now we don't have the bell-shaped curve, but we don't really need it. So in the pink we've got the population parameter there. You can see where my cursor is going vertically down and up the screen. That's the true population parameter. Okay, it might be the population proportion. We probably don't know that. Okay, usually you don't know that, and we can look at for a fixed population proportion. All right, and look, it doesn't really matter if we move it around, the whole thing shifts. Okay, so I'm just going to leave that alone. Okay, so I'll leave that there, 0.6. It doesn't matter greatly at this stage what it is. Sample size is something we're going to look at in the next video, but that does have an effect on the scenario. Keep that in mind for the next video. I'm just going to leave the sample size there alone, but the confidence level is what I want to show you. So we look at, you can see the blue dots here, which are basically the sample proportions for each of the samples, and the lines, whether they're green or red, are the confidence intervals. All right, and so if we have narrower confidence intervals, we find we get more red samples, which means the sample did not contain a population parameter at all. Okay, so the interval did not contain the population parameter at all, the samples interval. Okay, but if we have more confidence, we're more confident that the green or red which becomes green, okay, crosses that pink line at some stage there. Therefore, it has its interval has included the true population parameter. Okay, but of course these lines are getting wider and wider. There's an increased margin of error. Okay, so decreased margin of error, but look at the increase in the red intervals, and that means they did not include the population parameter. So there's your trade-off. So far we've looked at a number of things to do with confidence interval. The next video is going to look at the effect of sample size and how to determine the sample size, and part of that uses the margin of error.